All right, let's dive right in. Today, we are cracking open one of the most, truly, transformative technologies of our time, generative AI. We're going to get into how these amazing machines went from just, calculating things to actually creating things.
This question right here, it used to be pure science fiction, right? Can a machine really, truly create something new? Well, today, the answer is a massive yes. It's a reality we're all interacting with probably every single day. So the big question is, how on earth did we get here?
Okay, so to get our heads around how a machine can be creative, we first have to understand that AI isn't just one thing. Think of it like this. There are two major families of AI, and they each have a totally different purpose. And this is really the key difference in what we ask the AI to do. On one side, you've got what's called discriminative AI. This is kind of the old-school workhorse of machine learning. Its job is to be a classifier. It looks at something and asks, is this a cat or is it a dog? It puts things into boxes it already knows. But generative AI, well, that's the artist. It starts with a blank canvas, and its job is to create something completely new, something that's never been seen before.
So what's the secret? Well, it really comes down to their diet, what we feed them. Discriminative AI, it gets fed this super neat labeled data. It's like giving it flashcards. This image is a cat, this one is a dog. But generative AI? Oh no. It gets the whole buffet, the entire messy, chaotic, unstructured library of the internet. And we basically tell it, here you go, figure it out.
So you might be thinking, how in the world does an AI learn anything useful from that giant, messy pile of data? It seems impossible, right? Well, there's actually a fantastic analogy that makes this whole thing just click.
Let's do a little thought experiment. This will make it really tangible. Forget about computers, forget about AI for just a second. Picture this. It's just you and I hand you 10 different books, and every single one is about cats.
Okay, so after you read all 10 of those books, you're not just going to be memorizing the pictures, right? Your brain would start to see the patterns, the connections. You'd build this deep intuitive idea, an internal concept of what catness really is. You just get it. All the things that make a cat, the whiskers, the tail, the way they move.
And here's where the magic happens. Because you've learned those underlying patterns, not just memorized facts, you could actually generate new information. If I asked you to describe a cat that has purple spots and, wings, you could totally do it because you understand the basic rules of cat. In that moment, you have essentially become a cat model yourself.
And that right there, that perfectly illustrates what generative AI is doing. It's the exact same process as our cat book experiment. The only difference? The scale. It's a scale that is just mind-bogglingly huge, almost impossible for us to really wrap our heads around. So yeah, forget about just 10 books. We are talking about a truly colossal amount of data. A model like Llama 2, for example, was trained on something like 2 trillion tokens. And a token is basically a word, or even just a piece of a word. It's an unbelievably vast library that these models read to build their understanding of, well, pretty much everything. But look, it's not just about having more data or faster computers. That's part of it for sure. But the real question is, why is this all exploding right now? What changed? Well, it turns out there was one key technological breakthrough. A single invention that pretty much unlocked all of this potential. And that key was an architecture that came out of Google back in 2017. The researchers published this now famous paper called Attention is All You Need. It introduced something called the transformer, and I'm not exaggerating when I say it completely changed the game. It basically gave AI a brand new superpower. Okay, look at this sentence. The animal didn't cross the street because it was too tired. As a person, you read that and you know instantly it refers to the animal. Your brain just does it. It's effortless. You don't even think about it.
But for a machine, how does it know what it refers to? For a long time, this was a huge, huge problem. And AI just saw a string of words, one after the other. It didn't get the relationships. The transformers solved this with a really clever mechanism called self-attention.
What self-attention does, essentially, is it lets the model look at every single word in a sentence at the same time and figure out how important each word is to all the others. It literally weighs the relationships. So it learns, hey, this word, it, is super strongly connected to the word animal. And that is how it finally gains a real understanding of context.
Okay, so let's put it all together. We have our ingredients, right? We've got this massive pile of data. And we have this powerful transformer architecture that can actually understand context. So, what do you get when you mix those two things together?
What you get is a large language model, or an LLM for short. And this is the engine, the single foundational model that powers all the tools you're hearing about and probably using. Things like ChatGPT, Gemini, you name it.
And on the surface, the whole workflow seems pretty simple, right? You give it some kind of input, a prompt, a question, whatever. The LLM then takes that, uses all that training and its ability to understand context, to process it, and then boom, it generates a totally new original output.
And this is where you really see how powerful this is. I mean, look at all these different tasks. In the old days of AI, every single one of these would have needed its own, separate, highly specialized model. It was a ton of work and super inefficient. But now, one powerful model can do it all. And that really is the revolution we're living through. We've gone from AI being a collection of single-task specialists to having these multi-talented generalists. This one model can be a translator, a coder, a creative writer, a summarizer, pretty much all at once. It's made AI so much more versatile and accessible than it's ever been.
This really shows the jump in just how efficient and capable things have become. We went from one model, one task, to one model, many, many tasks. It's a total game changer. So let's circle all the way back to that question we started with. Can a machine create? And the answer is a resounding, definitive yes. And it's not magic. It's because it learned how to do two things incredibly well. First, find the deep underlying patterns in just a mind-boggling amount of data. And second, understand context using that attention breakthrough.
Which, of course, leaves us with a final and maybe even more interesting question. Now that the machines can generate, what should we ask them to create? The technology part is here. The real frontier now isn't about the machine's limitations, it's about the limits of our own imagination. So the real question is, what are we going to create with it?